Here's some problems from section 10.2, and these are just some vector problems. And number one, it just says vector from the origin of the point a equals 2, 3, and they just want you to find the component. Well, remember the component is just the horizontal change, vertical change, so we write it like this. It's going to be just change in x, change in y, and then the change in x would just be like, another way you could write it as x2 minus x1, y2 minus y1, kind of just like our delta x, delta y, and our slopes. So over here, this is going to be my x2, y2, the n, or the arrow is the 2, and the tail would be the 1s. So it's just going to be x2, which is 2 minus 0, and then 3 minus 0, and that's just going to be 2, 3. When it's in the standard form, when the tail is at 0, 0, then just these coordinates will give you the change in x and the change in y. That's what that is. So that's no problem. That's component form, horizontal change, vertical change. Now over here, this is a little bit different because we're not starting at the origin, so it's not in what we would call standard form. So again, we want to find the delta x, delta y, the change in y. So the change in x is going to be, this will be again, the arrow will be to 2's and the tail will be the 1. So x2 is 2, minus x1 is 1, and then y2 is negative 1, minus y1, which is 3. There you go. And then that's just going to be 2 minus 1 is 1, and negative 1 minus 3 is negative 4. So basically you have a horizontal change of 1 and a vertical change of down 4. Okay, number 5. They want us to find the magnitude of the vector in the direction angle it forms with the positive x-axis, and our first vector here is 2, 2. So when it's in this component form, we can almost think of it as in standard form, so we could graph it. And let's just say we go over 2 up 2, so this would be the point 2, 2. We want to find the magnitude. Well, the magnitude is real easy because this is also in this form A, B, and we know the magnitude of the vector. Let's say this is vector V, just for naming sakes. We know that the magnitude of vector V is just the square root of A squared plus B squared, its components. So 2 squared plus 2 squared, which is the square root of 4 plus 4, which is just square root of 8, or 2 times the square root of 2, so that's the magnitude. Square root of 8 or 2 times the square root of 2. That's going to be the magnitude of the vector, and we would notate that like that. And then we want to find the angle it makes with the positive x-axis, so this is theta we're looking for, that's the angle. Well, if this is 2 and this is 2, we can see that the tangent of the angle is the opposite over the adjacent. So the tangent of theta equals 2 over 2, which equals 1. And what angle has a tangent of 1? 45 degrees. So theta equals 45 degrees. So that's my direction angle. So it's pretty easy. Draw a sketch and kind of figure it out. And then you've got your definitions on the notes I gave you in class. So should be pretty straightforward.